Okay, so in this video, we're going to look at how do we solve a problem that has to do with related rates. And we're going to start here in this example. So we have a camera that is set up at the starting line of a drag race that is 50 meters from the dragster at the starting line. Okay, so and I'll draw this for us. So this is the drag race track here, and along this line is the starting line, and we have a camera positioned here at 50 feet. Okay, and 2 seconds after the start of the race, we have the dragster has traveled 100 feet, and the camera is turning at 0.75 radians per second while filming the dragster. So what we know is that after 2 seconds, the car has traveled 100 feet, and if we call this theta, we know that d theta dt is equal to 0.75. And they're asking, the first question asks us, what is the speed of the dragster at this point? Okay, so if I call this y here, then I want to know what is dy dt. So what I need to do is set up some equation that deals with theta and y, and if I call this x, that deals with theta, y, and x. Well, the one that makes the most sense is to say that tangent of theta is equal to y over x. And so if I solve for y, because remember I want to find dy dt, so I'm going to say that x tan of theta is equal to y, which means that if I take the derivative with respect to time, and that's important, we are wanting to take the derivative with respect to time. So I'm going to treat all these, both x, y, and theta, as functions of time and use implicit differentiation. So I'm going to do the product rule here. So this is a product between two functions, so I'm going to use the product rule. So I would have dx dt times tangent of theta plus x times secant squared of theta d theta dt equals dy dt. And keep in mind that dy dt, this is what I want to find. So I've got to be able to fill in the rest of that. Now, what we know is that x is the distance from the car to that first camera, and that camera is not moving. So therefore, we know that dx dt is equal to 0. So that means that this whole term right here can be canceled out. So then what I wind up with is x secant squared of theta d theta dt equals dy dt. So I need to figure out what x is. So that's one thing I need to figure out. I need to figure out what secant squared of theta is, and I need to figure out what d theta dt is. Now, we've actually been told what d theta dt is. That is 0.75 radians per second. Now, so I need to figure out what x is and secant squared. Now I know x is 50. So I have 50. Now I need to figure out what is secant. Okay. So secant is, in general, is going to be the hypotenuse over the adjacent. So what I have here, I'm going to go ahead and redraw this triangle. I have a triangle where this is 50 and this is 100. So this is the square root of 100 squared plus 50 squared. And this is theta. And so secant of theta would equal the square root of 100 squared plus 50 squared, all divided by 50. Therefore, secant squared of theta would equal all this squared, which would be 100 squared plus 50 squared, all divided by 50 squared. So that's what I put in here, 100 squared plus 50 squared divided by 50 squared. And notice that when I do that, this 50 cancels out with one of those 50. And so what I wind up with is 100 squared plus 50 squared divided by 50 times 0.75, and that is equal to dy dt. And when we do this, we wind up with 187.5, and that would be measured in feet per second. So again, the key here was utilizing a function. In this case, it was tangent, utilizing a function that dealt with theta, y, and x, because those are the ones that I knew. And in particular, I knew dx dt was 0, and I was looking for dy dt. Okay, now if we go back to the problem, we have a second problem here, and it says a second camera, which is located 100 feet from the dragster at the starting line, and it's asking how fast is this camera turning 2 seconds after the start of the race. So we have the same setup, but only now we're over here and we're looking at this same point here. So I have let me change this orientation. Okay, so what I have is this triangle here, okay, this is still 100, and this is 100, and this is, we'll call it beta. So this now is the square root of 100 squared plus 100 squared. All right. So now if I do the same sort of thing, now keep in mind, I'm wondering how fast this is rotating. So if I said tangent of beta is equal to y over x, then I would have x tangent of beta is equal to y. And then so similarly, I would have dx dt tan of theta, or sorry, beta, plus x times secant squared of beta d beta dt equals dy dt. Now we know from the previous problem that dy dt is equal to 187.5. We know from the previous problem that this dx dt will be equal to 0. So all we need is x, which is 100. And we need secant squared of beta, so that's going to be the hypotenuse over the adjacent, so that's going to be 100 squared plus 100 squared over 100 squared times d beta dt. Okay, so that will cancel with that, left with 100. So I basically have 2 times 100 squared over 100 times d beta dt equals 187.5. Now, note that this will cancel with one of those, and so you get d beta dt equals 187.5 over 200, which is what, 93 0.9375. So we'd say 0.9375 radians per second. All right, so that is the final bit of that.